question, we will be looking at the magnetic force on electric charges, as well as the motion of a charged particle in a magnetic field. Let's take a look at this question. Protons emerge from a source at a speed of 6.0 times 10 to the power of 6 meter per second into a region of uniform magnetic field of flux density 0.18 Tesla. The region is evacuated and the magnetic field is normal to the direction of motion of the protons. For part A, calculate the radius of the path of the protons in the magnetic field. For part B, state and explain what happens to the radius if the kinetic energy of the protons were to be reduced. Before we proceed to solve part A, let's try to understand how does the protons move when it is injected into this region of uniform magnetic field. Let's imagine we have a uniform magnetic field as indicated in the diagram. The magnetic field is directed into the page of the paper, indicated by the blue crosses. Take note, it is stated that in the question, the region is evacuated, meaning the region of uniform magnetic field is in a vacuum. The protons is directed such that it is normal to the magnetic field. So we assume the direction of motion of the protons to be in the direction of the green arrow, and it is perpendicular to the direction of the magnetic field lines. And how does the protons move in such a magnetic field? Well, it actually moves in a circular motion. But what provides that force required by the protons to move in a uniform circle? Take note that when a charged particle moves within the magnetic field, a magnetic force will be generated and it will act upon the charged particle. However, if the charged particle moves in a direction such that it is parallel to the magnetic field, then there will be no magnetic force acting on the charged particle. Let's look at Fleming's left-hand rule to determine the direction of this magnetic force when we already knew the direction of the magnetic field and the direction of motion of the charged particle. The thumb, as you can see in the figure on your right, represents the direction of the force. The index finger represents the direction of the magnetic field. Take note, magnetic field moves from a north pole region to a south pole region. The middle finger indicates the direction of the current, or it could be the direction of flow of positive charges. So if you orientate our left hand to correspond with the figure on the left hand side, where the middle finger points into the page of the paper, our middle finger follows a green arrow, which is the direction of motion of protons, where protons are positively charged particles. You can see that our thumb points vertically upwards, which is indicated by the black arrow. So this black arrow actually indicates the magnetic force. The magnetic force provides the centripetal force required by the protons to move in a circle. Now that we have understood how the protons move in this region of uniform magnetic field, let's proceed to solve part A of the question. Now, we already knew there is a magnetic force represented by F subscript B, which provides the centripetal force for circular motion. So, FB is equal to FC, where FC is the centripetal force. Now, the formula to calculate the magnetic force is B Q V, and the centripetal force is given by mv squared over r. Now, B represents the magnetic field, Q is the charge of the protons, and V the velocity of the protons. Here M represents the mass of the protons, and R represents the radius that we need to find. So, by doing some rearrangement, we have R equal to mv over qb. So if we know the values of the four variables on the right hand side of the equation, we can solve for the radius of the path of the protons in the magnetic field. Do we know these values? Yes, we do. Now, the mass of the protons, if we check the formula booklet, is given by 1.67 times 10 to the minus 27 kg. The velocity is given as 6.0 times 10 to the power of 6 meter per second. Take note, we have to put all these values of the quantities in SI units. Right? Then we divide this by the charge Q of the protons. Now the charge is known as 1.60 times 10 to the minus 19 coulombs. And the magnetic field is given as 0.18 Tesla. So upon calculating, we find that the radius is 0.348 meter. So we have solved part A of the question. Let's look at part B. Now part B requires us to state and explain what happens to the radius if the kinetic energy of the protons were to be reduced. Now, I hope you can see that the radius is actually proportional to the velocity of the protons. From this equation, you see on top. So, if the protons K is reduced, their speed will be reduced. Then, the radius r of the path, which is directly proportional to the speed v, will be also reduced. I hope this example will give you a better understanding of how protons move within the uniform magnetic field, as well as the relationship between magnetic force and the motion of a charged particle in a magnetic field. Thank you.